So, welcome to my class. Now, today we are going to start with lesson number 1, relations and functions of class 12. So, what do you want? So, today in this class, we'll study about relation, the whole relation in one shot. Okay. Now, let us start with relation. What is a relation? Now, suppose you are given a is equals to 1, 2, 3 and b is equals to 1, 2, 3. Okay, now let b also be equal or 4. Okay, now if you want to make a relation, you can make it like this, but there are many conditions given to make a relation. But now today we will just learn basic about relations. So if you want to make a relation, then 1 can be made, 1 2 can be made, 1 3 can be made, 1 4 can be made. Now you can make it any made, 2 1, 2 2, 2 3, 2 4. That is your choice. Now, how to write a relation? Relation is written and denoted like this. Now it is 1, 1, 1, 2, 1, 3, 1, 4, up to so many can be made if a condition is not given. But if you are given a condition that a can be a comma b belongs to natural number such that a is equals to any natural number, but b is equals to a plus 1. Now here you are given with a condition. Now in this condition you should be very sure. Okay, now let us remove b. Now if like this you are given, then to make a relation, suppose it is a1. Now you can write in place of a, you can write 1. Now what will be b according to given condition? B will be a plus 1. A plus 1. So what will be 1 plus 1? It will be 2. So you can write it here 2. Now what will be? Now what will, if you take 2 in place of a, what will be the 2? Now what will be b? It will be 2 plus 1. That is 3. So this is how you make a relation. This is basic knowledge. Now starting with 12th standard about relation. Now there are many types of relation. So there are relations like empty, universal, identity, reflexive, symmetric, transitive, and equivalence. Now you should be familiar with empty, universal, and identity. So let us revise once empty, universal, and identity. What is empty relation? A relation which does not contain any element means it is empty. It is considered as an empty relation. Now what do you mean by a universal relation? A relation which contains all the possible ordered pair is supposed to be a universal relation. What do you mean by identity? Identity means it is same. A relation containing all ordered pairs wherein both the elements are same is considered to be an identity relation. Now talking about reflexive relation, we have to study in 12th standard. Now first reflexive relation, we will study it in details. Okay, now start it. So if you want to note, you can note the definition of reflexive relation. Reflexive relation. So what do you mean by reflexive relation? In a relation, whatever number of elements are there, whatever number of elements are there, if every element of a set is related to itself, then we can say it is reflexive. Then we can say it is a reflexive relation. Now this is the definition. You might not understand. So let us work with an example. Okay. Now we will take an example. If you want to note, you can note it. Now talking about the example, suppose you are given with a relation that R is equals to 1, 1, 2, 2, 1, 2, 2, 1. Okay, now if you are given with a relation and if you are given that x comma y belongs to n and x is equals to 1 comma 2 comma 3. So can it be a reflexive relation? According to definition, let us see here. 1 is related with 1, yeah, okay. 2 is related with 2, yeah, okay. But here 3 is 3 comma 3 given? No, this is not present. So we say it is not a reflexive relation because it should be related with its set. X is given 1 comma 2 comma 3. So 1 is related to 1, 2 is related with 2, but is 3 comma 3 present? So it is not present. So it can't be a reflexive relation. Now let us talk about symmetric relation. Okay, symmetric relation. Now let us talk about symmetric relation. What is a symmetric relation? Symmetric relation. Symmetric relation. What is symmetric relation? If a number is related to some other number, the vice versa should be possible, then and then only it can be classified as symmetric relation. Now according to definition, if a number is related to some other number, if a number is related to some other number, the vice versa should be possible, then and then only it can be classified as symmetric relation. Now let us study by taking one example. Okay, now if you want to note, you can note it down. Now symmetric relation, if you are given with one example like this, r is equal to 1 comma 1, 2 comma 2, 3 comma 3, then 2 comma 1, 1 comma 2, then 3 comma 2. Now if you are given with this relation, and if you are asked verify is it symmetric or not. Now first of all, according to definition, vice versa should be possible. So there is a need to check this with 3? No, there is not need, because 1 comma 1. What is the vice versa of 1 comma 1? It is again 1 comma 1. So it is it can be considered a symmetric relation set. Now what is if is this 2 comma 2 is present? Again 2 comma 2 is present. So no need to check this also. Now about 3 comma 3, this is 3 comma 3. Now again vice versa is 3 comma 3. So no need to check if both are identical. Okay, now let us talk about this thing. Now 2 comma 1, you are going to 2 comma 1, the vice versa of 2 comma 1. 2 comma 1, what is the vice versa of 2 comma 1? It is 1 comma 2. So if is 1 comma 2 present? Yes, 1 comma 2 is present. Now but talking about this, you have to see all the elements. Now talking about this 3 comma 2, what is the vice versa of 3 comma 2? It is 2 comma 3. Is 2 comma 3 present in this set?
No.
Is 2 comma 3 present in this set? No, it is not present at all. So we can't say it is a symmetric relation. But if here it is given 2 comma 3, then we can say this relation is a symmetric relation. So I hope you understand. Now the left one, that is transitive and equivalence. So let us first talk about transitive relation. Transitive is quite confusing, but you will learn it. Now transitive relation. Now talking about transitive relation, if x is related, this is the symbol of related, to y, and y is related to z, then if x is related to z, then and then only we can say that the relation is transitive relation. So you might be confused. If x is related to y and y is related to z, then if x is related to z, then and then only we can say that the relation is transitive relation. So now taking examples. Yeah. Again, if we take example, if it is again like it is given, r is equals to 1, 1, 2, 2, 3, 3, and it is 1, 2, again it is 2, 1, then if you have 3, 2, no, okay, you have 2, 3. Now suppose it is given like this. Now condition for transitive relation: if x is related to y and y is related to z, then x should be related to z. Now what do you understand by this? Suppose if x comma y is given and y comma z is given, then the need to make this relation transitive is x should be related to z. If here again a set is given x comma z, then we can say it is transitive. But if talking about this example, let us see. Now in transitive relation, the identical are always transitive. So remember that the identical are always transitive. So no need to check 1, 1, 2, 2, 3, 3. Okay. Now talking about this. Okay. Now 1, 2 and 2, you have to see 1, 2 is there and 2, 1. You have to see the second element of one element and the first element of another element, if they are equal. So it is 1, 2 and 2, 1. If these are given, then here 2 is equal and 2, then x is related to y. Okay, x is related to y and y is related to z, and x is related to y and y is related to z. But are x and z related? Is there a set 1 here present? Yeah, it is present. So now okay, this condition is fulfilled. Now you have to see all the elements. So I have told you. So again 2 is here, the second element of one set and the first element of another set. Again we have to match this 2 also. So 2, 2, x is related to y and y is related to z. But are x and z related? Is there a set 1, 3? No, it is not present. So if 1 also it is not present, then we can't say it is a transitive relation. So if it is given like that, again, if it is given like that, 1, 3, if 1, 3 is present in here, if 1, 3 is present here, then you can see 2 are equal, so 1, 1 is present. Now again 2, 2 and 1, 3 is present, so we can say this relation as a transitive relation. This is the condition for a transitive relation. I hope you have understood. Now the last and the least, the equivalence is very easy. If a given relation is reflexive, if we talk about equivalence, relation, if we talk about equivalence relation, then when a relation can be equivalence, if a relation is reflexive, symmetric and transitive, if it satisfies all the three cases, then we can say it is a equivalence relation. If a relation is not symmetric, if a relation is not reflexive and it is symmetric and transitive, then we can't say it is a equivalence relation. The condition is reflexive should be the relation should be reflexive also, symmetric also, and transitive also. So no need to example, we can take one example. So let us take one example. Now here only we will take example. Suppose I take a set 1, 1, 2, 2, 3, 3, then 1, 2, then 2, 1. Now this is a simple example I have taken for equivalence relation. Now you need to be very particular about this. Is it a reflexive relation? Is it a reflexive relation? Is 1 related to 1, 2 related to 2, and 3 related to 3? Yeah, so it is reflexive. It is reflexive. Now checking out the symmetric. See if it is it symmetric. Is the transverse possible? 1, 1, yes. 1, 2, 2, yeah, it is possible. 3, 3, it is possible. 1, 2, and is 2, 1 present? Yeah, 2, 1 is also present, so it is symmetric also. So we can write it is symmetric. It is symmetric. Now talking about transitive, as I already did, you not need to check this 3. Now talking about this 1, 2, and then see 2 are equal. So we need to check this 2, 2. So 1 should be related to x, x is related to y, and y is related to x, y is related to z. But is x related to z? Is 1, 1 present? Yes, 1, 1 is present. So we can say it is transitive also. So now we can write therefore first we can write it is a relation is reflexive, transitive, and symmetric. Therefore it is a equivalence relation. Now if we add here, if we need to talk, and if we add here, suppose we add that example same 2, 3. So now it will be an equivalence. Let us check. It is reflexive. Yes, it is symmetric. 1, 1, 2, 2, 3, 3. But 1, 2, then 2, this transfer is 1, 2 is there, 2, 1 is there. So this both are symmetric. But what about this 2, 3? Is 3, 2 present? No. So it is not symmetric. And let us talk about transitive. It can't be transitive also, because if we take this both, then 2, 2 is here. But is 1, 3 element present? No. So it is not equivalence, because it is not symmetric and not transitive. Okay, I hope you understand. So we will end with this lecture. So thank you everyone.